All right, let's look at problem 12. All right, I said I'd do problem 12, but there's nothing to it. Okay, here, God dang it, been that kind of day. All right, so just treat it as 410 volts AC. You don't have to take like the square root of 2 or divide by the square root. I looked up the answer just to make sure. I thought they weren't being fancy, so it's 410 volts AC. So we'll just send that. That's the average. That's the RMS voltage, and then you just what's the effective resistance, because resistance doesn't care if it's AC or a resistor just stays the same. It's a physical thing. And then you just figure out the kilowatt hours, because remember, you find out the total hour, find the kilowatts, and multiply by the total hours that it's working. And so there you go. So the power here is so look at this. Power is kilowatts. So you just take the kilowatts, 49 kilowatts, and multiply it by the number of hours. What are they talking about? Air conditioner in a hot summer when it's 8 hours a day for 30 days. So there's 24 times 8, 240 hours times that. That should work. That ain't no big deal. But I really wanted to talk about this because find the RMS current through a person. Okay, so 125 VRMS. All right. And so we'll just leave it at that. That's the 120 volts. That's the RMS current coming through. And you don't need to worry. You don't need to divide by the square root of 2 or multiply that by the square root of 2 to get the maximum voltage. We're standing on which has a resistance of 275 kilo ohms. Find the answer in milliamps. All right. So, well, that's not hard to do. I mean, that's pretty easy to do. So we'll just do this. We'll take for some reason something just clinked. So let's take not problem B. It's problem 13. All right. So shoot, I forgot to write down the information. I'm sorry. V is equal to 120 volts, and R is equal to 275 kilo ohms for part A, and then again it drops the voltage, the resistance drops quite a bit in the wet grass. So this is R for the mat, R for the grass, and you'll see all this stuff here in a minute, is equal to 3950, just ohms in this case, or 3.9 kilo ohms. All right. So let's look and see what I've got written down here. Whoop, wrong thing. Okay, so this isn't hard. So I is equal to, and I'm going to go back to that page from your book. All right. So I for the mat, V equals I times R. So it's V over R. Now you got to be careful. So you got 120 volts divided by 275,000. And this is, and when I do this, I'm going to 275,000 ohms. So I take 120 divided by 275, 1, 2, 3, and I get 4.364 times 10 to the negative 4 amps. All right, well, let's see what it is in milliamps. So I in milliamps, I multiply that by 1,000. I multiply that answer by 1,000. I wind up with 0.4364 milliamps. All right, so what's the sensation? Is that going to hurt anybody? Well, I've added this. I'm going to add this to your top hat thing, this table here. And this is all in milliamps. And I need to turn off my freaking... Oh, God, I can't do it. All right, anyway. Jesus. Sorry. I just have moments when I can't turn stuff off that I want to turn off. All right, so anyway, so threshold of sensation is 1 milliamp. So we barely, so you don't even feel it. You don't, the threshold of sensation is 1 milliamp, and we've only got 0.43 milliamps. So on the next one, let's go ahead and do the next one, because this is kind of a teaching moment here. So what does the next one say? This is for, she's standing on wet grass, and it's that voltage source. So I of grass will be 120 is equal to 120 over 3950, and then 3950. So I got 120 divided by 3950 is equal to 0.0304 amps. Milliamps, I grass in milliamps will equal times 1,000. 30.4 milliamps. All right, so 30.4 milliamps. Let's see what that how the human body reacts to that. Just for 30 point. So it's right here. Onset of pain. There's definitely, it's right. It's 10 to 20. You're going to feel a contraction of the muscles, and we're getting close to the onset of pain. So you're gonna feel, dang, that hurt. All right, that's a dang, that hurt. Luckily, it won't kill you. Look at the 6 amps. Those of you who mess around with MRI machines, that's the kind of amperage going through that thing. Got to be careful. And this is milliamps, 300 milliamps. You know, there's not much there. All right, so out here, before my text blows up again and you get into my personal business. Bye.